So I'm Nolan Lawson. I'm on the web platform team. In particular, I'm on the performance team. So I focus on things like how can we make the browser faster? How can we make it more competitive? But then also, how can we make websites faster? So I spend a lot of time talking with web teams inside of Microsoft as well as outside of Microsoft. I probably met with many of you in the room before. Raise your hand if you've done a performance club with the Edge team. Okay, cool. Yeah, you guys know. Yeah, so we meet with web teams and we tell them like, hey, tell us where our browser could be faster. They do, and then we say, hey, here's how your website could be faster in all the browsers. So I spend a lot of my time doing that. I'm also really active in the open source JavaScript community. I co-maintain a JavaScript database called PouchDB. I've implemented WebSQL in Node. I don't know why. Just seemed like a good idea at the time. I've written a lot of browserify transforms, a lot of Node tools. I actually checked recently. I think I've written over 100 NPM packages. So if you're tired of JavaScript fatigue, I'm a little bit to blame for that. I'm sorry. So let's talk about the web performance crisis. So as with any addiction problem, really the first step is just kind of admitting that you have a problem, right? This is what they say. And so I'm going to start off with some kind of sobering statistics to hopefully convince you that we really do have a problem in our industry. Actually, we have kind of a collective problem. I'm not trying to lay the blame on web developers. It's a problem that we kind of all share, that we are failing to build fast websites, just as industry-wide. Not just at Microsoft, but industry-wide. So here's some sobering statistics. So this is from DoubleClick this year. They say 53% of mobile site visitors will abandon the page if it takes longer than 3 seconds to load. Okay, so keep that figure in your mind, 3 seconds. At the same time, the average load time for mobile sites is 19 seconds on 3G. This is how badly we are failing. 19 seconds. People will give up. They'll tap the link. If it takes longer than 3 seconds to load, they will just abandon it. And yet the sites are taking 19 seconds to load. It's awful. And you might look at this and say, oh, okay, well, that's 3G. But, everyone's on LTE, and LTE is getting faster and faster. So, 3G doesn't matter at all, right? Except that it kind of really does, because, in fact, LTE is not getting faster. It's getting slower. So there is this report by TwinPrime from just a few months ago, where they say that actually what's happening in the U.S. and as well as a lot of other places is that LTE networks are actually getting bogged down. They're getting more and more users piling on, and the effect is actually that LTE has slowed in the U.S. by 50% in the last year. So when you're on LTE, you're actually not on 4G speeds a lot of the time. Effectively, you're on 3G speeds a lot of the time, or even 2G speeds, or even offline. This is the reality that we're facing on the mobile web. And so then you're saying to yourself, okay, well, I build desktop apps or desktop web apps. Mobile doesn't really matter that much to me, but actually this problem is really across the entire web. So here's some just general statistics from Pingdom a year ago, where they say the average web page in 2015 takes 5 seconds to load, so just across all devices, mobile, desktop, and weighs 3 megabytes. 3 megabytes. So that's kind of big. Actually, it's big enough that, as Ronan Kremen very funnily pointed out here, we've actually reached the point now. We've reached this point, yes, where the average web page is bigger than a Doom install. He joked about it a couple of years ago, saying like, we're reaching this point. It's going to be bigger than a Doom install, and now it is. So we finally reached this point. He writes a blog post called "The Web is Doom." Oof. There was another great article from Maciej Siglowski that I strongly recommend. It's really funny. It's a great read. Here's just one small quote from it, where he mentions that there's an article called "The Overweight Web" that warns that the average page size is approaching 2 megabytes. That very article is 3 megabytes. So this is really the state that we're dealing with. This is the state of the web today. And really, we're all guilty of it. It's kind of it's a guilt that we all kind of collectively share. So this particular article that he mentions, I actually looked at it just out of curiosity. I loaded it up in webpagetest.org, which I'm going to talk about later. And I wanted to see what the actual content breakdown was. And it turned out that most of this page telling you why your websites are bloated is mostly JavaScript. If you look at this, it's about 48% JavaScript. That purple part is images. We got CSS in green, fonts in red. And I thought this was actually great because to me this is kind of emblematic of what's happening with the entire web. This is not an anomaly. This is kind of the reality that we're dealing with. It's just this JavaScript share is getting really, really huge. That's 870 kilobytes of gzip JavaScript, by the way. So before gzip, it's probably somewhere between a megabyte, 2 megabytes of JavaScript. So the average JS per page, here's what it was in November 2010, according to the HTTP archive, 113 kilobytes. Supposedly that's gzipped. Anyone want to guess how much this has grown in November 2016? Anyone want to shout out how many times? Okay, you guys are really pessimistic. It's not that bad, but it's grown to 420 kilobytes. So it is up 372%, and actually the overall size of pages has only gone up 352%. So JavaScript is exceeding, like JavaScript is growing faster than the rest of it. The share of JavaScript is increasing as well. And this should be especially troubling to you if you understand how browsers consume websites and what that impact on performance is, because there used to be this mantra that, like, you know what, shipping more and more JavaScript, it's not such a big deal because I can ship more and more JavaScript. I'll just, like, trim down my JPEGs a little bit. I'll just ship one less JPEG, right? Because, like, 1 megabyte of JavaScript, 1 megabyte of JPEG, what does it matter? But the problem here is that the truth is that JavaScript weight is actually way, way worse than image weight. In terms of impact on page load time. And the reason for this was nicely laid out by Sam Saccone at this year's Chrome Dev Summit. He had this really great talk I recommend watching, where he mentions, here is the time to parse JavaScript on different devices. So what he's got here is that is a Galaxy S7 on the left, and you can see that to parse 1 megabyte of JavaScript, which is, he's talking about non-gzipped JavaScript. So this is probably pretty close. Actually, this is probably less than what that overweight web article had, will take 1 full second to parse on a Galaxy S7. 1 second just to parse JavaScript. Okay, this is not transferring JavaScript. This is not executing JavaScript. This is just parsing it. Just merely parsing JavaScript. And then that is a Nexus 6, or no, that's an iPhone 6. That's also taking a second to parse. And then a Nexus 5 taking nearly 2 seconds just to parse JavaScript. So yes, JavaScript has a worse impact on your page, has a heavier impact on your page than other types of resources. And this is really the story that I see across every website. When I meet with teams and I do a trace of their website and I tell them what's slow about it, it's almost always this. It's this thing that Alex Russell on the Chrome team and I have started calling the big yellow slug, because this is how it looks in the Chrome timeline. You open up the timeline, you do a trace, and you see they color JavaScript as yellow. And you see this big, gigantic slug of JavaScript, which is basically just parsing and executing JavaScript on first page load. And this is like, if this is what your site looks like this is quite typical. And this is really, to me, the story of how the web is getting so slow. This is a big part of the story anyway. So how exactly did we get here? Well, I think it's actually not, I think it's actually a positive story. There's a positive side to why we got here. The reason we got here was summarized quite eloquently by Tom Dale a couple of years ago, where he said, in the past few years, something really funny happened on the web. The browser transformed from being this awesome interactive document viewer into being the world's most advanced, widely distributed application runtime. Right? Browsers got amazing. Browsers got amazing features. HTML5 became very well supported across all browsers, and we ended up with a situation where we had this amazing environment for building applications, right? Like, we've got more tools than we know what to do with. We've got tools that rival native development. We've got tons and tons of JavaScript APIs available in the browser to build these rich, interactive client-side experiences. And so more and more we started pushing more and more logic onto the client, right? Instead of building these server-side MVC apps like we used to build in the late 2010s, like the kind of classic Rails or Django app, we're building Angular apps, we're building React apps, we're building apps that have lots and lots of JavaScript, are pushing more and more logic to the client side because it's really kind of comfortable to develop that way, and browsers are capable of handling it now. But the problem is that is pushing more and more work onto the client, and performance has not caught up yet. So what I will argue in this talk is that when you build with JavaScript frameworks, they are actually slow by default. So if you do nothing else, if you just build a typical React, Ember, Angular app, they are slow by default. You have to actually work really, really hard to make them performant. And hopefully I'll be able to convince you of that in this talk, and I'll be able to show you lots of the tips to actually make it performant. So there are lots of ways to make your website faster. You could talk about Google's Rail model. You could talk about minifying images, minifying CSS. This is going to be a talk just purely about shipping less JavaScript and how we do that. There is a lot to cover just on that subject alone. So there's going to be a few parts to this talk. I'm going to start off by talking about measuring, because you can't improve what you can't measure. going to talk about trimming our third-party dependencies, because that tends to take up a lot of our JavaScript bundles. I'm going to talk about optimizing our JavaScript bundles. I'm going to talk about code splitting, how we take a big bundle and break it up into a few small bundles. I'm going to talk about server-side rendering. How do we do JavaScript without JavaScript? And I'm going to talk about component pre-compilation, which is some really exciting stuff that is just now starting to emerge in JavaScript frameworks. Okay, part one, measuring. Web page test. Who here has used web page test? It's awesome. Okay, use this tool. By the way, the rest of this talk is going to go really fast. I'm not going to give you enough time to figure out or to read all the tool names and everything. You might have to go back and look at it later. But again, this is why I'm giving you all the URL at the bottom. So web page test is really awesome. This is you go to this website, you punch in a URL, it will give you kind of a breakdown of how much. It'll give you the content breakdown, like what percentage is JavaScript, images, CSS, etc. It'll give you a timeline view. This is a trace for one of my favorite websites, which is purple.com, which is just a site that gives you a background that is purple. It is a very fast site. If you want the color purple, this is the fastest way to get it. This is a great website. You can learn a lot about performance from this website. You should look up to this one. So web page test is great. That's great for doing synthetic tests, though. Or if you want to test against like kind of the same machine running the same browsers over and over again. But we also want to test out in the wild. You want to know what your users are actually experiencing on their actual devices. For that, you've got the window.performance API. This is a W3C standard. It's widely supported in browsers. You've got things like performance.timing, where you can see when did navigation start happen? When did the user actually press enter to start navigating to that URL? When did DOM content loaded happen? When did load event end happen? You can get all of this stuff. It's available on every single website. There's also a performance mark and performance measure, which you can use to set breakpoints and to say, okay, I want to start measuring from this exact point in my JavaScript until this exact point. You can name them whatever you want. And recently in the Chrome DevTools, they actually started showing it in this kind of nice hierarchical way. We've actually been supporting it since forever, since like IE 10 in the DevTools. But thank you, Google, for kind of bringing it to a wider audience. So, but it's not just great because it shows up in the DevTools. It also shows up in a programmatic API. So you actually have access to this in window.performance. So there's good reason to use these APIs. They're not supported in Safari. Whatever. Just don't do it for Safari. Resource timing, another thing that is really, really useful. You can do performance.get entries by resource. This will tell you all of your assets, CSS, JavaScript, whatever. It'll tell you how long it took to request that thing and then to download it. Really, really useful API. Or there's also stuff built on top of all these things. You can use Microsoft App Insights, Google Analytics, Pingdom, Shasta. There's like a million of these things. They usually go under the name RUM, Real User Measurement. So web page test, real user measurement. Okay. Part two, trimming our dependencies. So, all right, we figured out how to measure. All right, we figured out how to measure in terms of here's how long it took to do this JavaScript operation. Here's how long it took for this thing to download. But what we really want to do is we really want to get insight into our JavaScript bundles and figure out what's kind of going on in there. Right? Who here is using a module bundler? Browserify, Webpack, Rollup, Closure. Pretty much everyone, I gather. Who's actually looked inside of it? Okay. So you've actually peeked inside to see how the sausage is made. It's not always pretty, right? Let's talk about that sausage. So what you want to use is you want to use a tool that can let you see what that sausage looks like. This is Webpack Bundle Analyzer, showing a bundle with Lodash, MobX, and you can actually use this to navigate around and see exactly how much each of your third-party dependencies is taking up, which one might be taking up more than you'd expect. Maybe you look at something and you're like, okay, I didn't realize that, Bluebird took up that much. Maybe I don't want Bluebird in my package anymore. So this is incredibly useful. There are lots of these bundle analyzer tools. If you're using Webpack, you have Bundle Analyzer and Visualizer. The one I just showed was the Bundle Analyzer. If you're using Browserify, there's a tool called Discify that can do the same kind of visualization. And then if you need a generic solution, there is the Source Map Explorer, which will work for any source map. It even works for CSS source maps. And you just point it to it, and it gives you this nice visualization showing you exactly how much each of the little components is taking up. There is a coverage extension for Chrome made by Sam Saccone that will show you exactly which lines of JavaScript in your bundle are actually being used in your app. So you navigate to your site, you start clicking around, or you start this tool running, you start clicking around, and then you look at the tool, and it'll tell you exactly which lines of JavaScript were actually executed. Like here, it'll tell you this file was barely used, this file was 100% used, and it'll actually show you line by line which lines of JavaScript were used. So another great way to get insight into your bundle and figure out, okay, do I really need this bit? Do I really need that other bit? Another great tool you could be using, a lot of modules, a lot of packages out there in the ecosystem offer modular APIs. So this is an example from Lodash. Everyone see that okay? Should I zoom in? Is that okay? So for instance, if you were to use Lodash in kind of a naive way, you might say, require Lodash.times, because you want the times API. If you do that though, you're pulling in all of Lodash. This is going to end up being 72 kilobytes, which is kind of big if you're just using that one function. So what you can do instead is Lodash offers a way to do require Lodash/times, then you just bring in the times function and its dependencies and not all of Lodash. And then that is much smaller. That's 3.4 kilobytes. And then it turns out if you don't want to do this kind of manual thing over and over again, JDD is awesome. He's actually built a lot of tools to kind of automate this. So there's a Babel plugin Lodash and a Lodash Webpack plugin that can do this stuff for you. But the second method is the foolproof method. And there's lots of libraries out in the ecosystem that do this. Lodash is just one of them. React does this, D3 does this, my own PouchDB does this, Firebase does this. So go and check to see if they have some kind of modular API and start preferring that instead of just bringing in the whole thing. And then also check out to see if there's any smaller alternatives to the stuff you're using. React has a clone called Preact, which is way smaller. Instead of jQuery, you can use Zepto. Instead of underscore, you can use Lodash. Bluebird is huge. Lie is not. Also has a great name. It's a promise polyfill called Lie. I love it. This is another really cool tool that you could use instead of these third-party dependencies, polyfill.io. I really love this thing. This is maintained by Financial Times. It's a super cool service. You just drop it into your page, and basically what it does is the server UA sniffs. I know you shouldn't be UA sniffing, but they're maintaining this thing really, really well. UA sniffs, and then it serves up exactly the polyfills that browser needs. So if you get the default polyfill, what you'll see is that Firefox gets the smallest bundle, right? Because I guess Firefox has implemented the most of the default web APIs. And then IE11 is the one that gets the huge bundle. That's the one that gets 26 kilobytes. And so essentially what you're doing here is you're not punishing the new browsers, right? The new browsers don't need to be punished. They have Promise, they have Fetch, they have all this stuff. You shouldn't be punishing them with polyfills, right? So punish the old browsers, especially punish IE11. Get people off of IE11, please. This is another great way to do that. And you can actually go in here and you can tell it, like you can pass in query parameters to say, only give me the Fetch polyfill, only give me the Promise polyfill, etc. So this is a really, really cool service. And it's open source, so you can run it on your own servers. Okay, part 3, optimizing our bundles. Is it going okay? Am I moving too fast? Is this all right? Okay, so this is a really interesting part and kind of dovetails a little bit with the previous talk. Be aware of Babel costs. So we all love Babel. It's really great that we can use these ES6, ES7, ES20, whatever. I can never keep them straight in my head, which one's which. But it's really great to use these features today, right? But they have a cost, and it's not always clear. It doesn't always make it clear to you what those costs are. So here's an example. So we were talking earlier with Ryan about classes. Here's a really simple example of a class extending another class, right? You got class foo, and class bar extends foo, right? So this is super, super simple. Anyone guess how big this actually ends up being when you transpile this with Babel? Anyone? Okay, it's 23 lines. It ends up being this. And this actually gets repeated every single time you use classes, over and over and over again. Yes, it's just over and over and over again. To the credit of the Babel team, it's not that they're dumb. Actually, they're doing this on purpose. They're trying to be spec compliant. So this does serve a purpose, but it is kind of bloating your bundle by including it in there. Now, it turns out there actually is a solution to this particular problem. There is an alternative to Babel called Buble. This is the actual name of this thing. It's a lightweight Babel alternative. Basically what it does is it's a zero configuration Babel alternative that gives you like 5 features. It gives you like the 5 features that everyone wants for the most part, like arrow functions, const, let, classes, one other thing. I think it's like the backtick strings or something. Like the 5 that everyone actually uses. It just gives you those, and it doesn't output nearly as big of a bundle. So this is the version that it gives you for that same example I gave before. This is more like what you would handwrite if you weren't using classes, right? And the trade-off that Buble is making here, to be fair, is it is not 100% spec compliant. It's like 99% spec compliant. But you know what? It's probably good enough, right? So Babel and Buble have different trade-offs. You might want to use Buble instead of Babel. Here's another good example of how Babel adds to your bundle size. This, we're using an ESX feature here, which is the of, right? He's saying I'm saying var bar of foo, or instead of in. You want to guess how big this becomes? Just using this one keyword, of. Once again, this is about 22 lines of code. So every single time you use of, you get this. So, do you really need of that badly? Maybe not. Maybe in is okay. How about async await? We all love async await, right? It's amazing. I love async await. Actually makes promises usable, right? But anyone want to guess how big this ends up being when you transpile it with Babel? Anybody? So the answer is big. So you need to use the Babel regenerator plugin, which kind of compiles async await into generators, and then you need to use the regenerator polyfill so that it can work in browsers that don't have generators. Anyway, it ends up being really big. It is this big. So there is a nice solution to this from the perspective of the Babel team, which is that, so they have a thing now called Babel preset M, which this just came out like a couple weeks ago, so this is totally new, which is a new Babel preset where you can set which browsers you actually target, and then it will automatically figure out which features you need in order to support those browsers, and it won't transpile all the other stuff. So if you tell it, like, hey, I'm supporting latest Chrome, Edge 14, Safari last 2 versions, as long as it has at least 10% usage, then it will just figure out, okay, you know what, the for of loop or whatever, all these browsers actually support that, so it's fine. I don't need to transpile it. So this can be really, really useful. I advise you to look into this. Or, you know what, just don't use the features yet. Like, you don't need them that badly. Like, it's another option, just throwing it out there. Okay, tree shaking. This is another cool feature that module bundlers are supporting more and more. So tree shaking is this awesome idea that, hey, not every library out there supports modular builds. Lodash does. That's really great. Shout outs to JDD for that. Not every library does. So let's say I'm using jQuery and I'm only using $.ajax. I'm not using any of the rest of it. It's kind of a shame that I'm including all of jQuery in my bundle, right? I would like to just use $.ajax. Well, with tree shaking, now you can. Now you can. Now you can. I just really want to drive the point home that you really can. So this is an example of tree shaking. So I've got this module right here where it exports 2 functions, A and B, and I'm only using A. And I import A from that module. And hey, what do you know? If you look on the right at the output bundle, it doesn't include B. Isn't that magical? And this is thanks to modules and thanks to tree shaking. So, and it just does that automatically. The library author didn't have to offer any kind of special API to make that possible. So there's only a few module bundlers today that support this. The one I just showed was Rollup. Google's Clojure compiler also does. System.js, which uses Rollup, can do this. Webpack 2, which is in beta right now, has this feature. And Webpack 2 is pretty stable, I would say. So if you want to upgrade to Webpack 2, it has this out of the box. The one thing you need to know is that for this to work, you should use ES modules. This doesn't really work with CommonJS, so it doesn't work with module that exports and require. You need to use the new import and export keywords. And if you want, I've written a tool called CJS to ES6 that can mostly transpile CommonJS to ES6. There's some stuff you have to do manually, but it can transpile most of your code base. Okay, module bloat. So this is another really, really interesting issue. If you look at your bundles, what you'll notice, this is a Browserify bundle, and this was a little test I ran where I essentially bundled together like 100 different modules, and each of the modules are super tiny. And what you'll notice is there's kind of this repeated code over and over again, right? If each bundle gets its own function wrapper. You get a function, you get a function, you get a function. Every module gets its own little function wrapper. And you compare that to something like Rollup. Rollup, it's interesting because what they do is instead they have each module just as a variable that is declared instead of one gigantic function, right? And you might think, well, this is like, 6 of one, half a dozen of the other. What does it matter? Well, it turns out it matters a lot, actually. So I wrote this blog post a couple of months ago called The Cost of Small Modules, where I kind of exposed this difference between the different module bundlers. And what you'll see here is this is a Nexus 5 that I tested on, I think, throttled to 3G. And if you look at the amount of time it takes to download and execute these bundles, it's vastly different between the different bundlers. So Browserify will take 400 milliseconds to download this bundle, and then 200 milliseconds to execute it, whereas Rollup will take 200 milliseconds, and it's barely a blip to execute it. And by the way, this is just overhead of modules. Like, in this benchmark, each module just exported a number, and I just added the numbers together. So this is purely the cost that you are paying of having so many modules. And this cost grows and grows the more modules that you add. And it's very, very subtle, because what you think of as a module, like when you import a package from NPM, you might think, oh, that's just one module. But actually, it might import other packages, right? And even if it's just one package, under the hood, it might have multiple files. Each of those files could be a module. So typical JavaScript bundles out there, I measured a few different websites, like I think Apple and Reddit, and they had around 1,000 modules. So that's pretty standard. So module bloat is a serious thing. Just the more modules you have, the sheer number of the modules, it starts to weigh you down. So the lesson is you want module bundlers that have this kind of inlining capability, that give you, variables instead of everything getting its own little function. The bundlers that do this are Closure Compiler and Rollup. Splittable is a new one that just came out, which uses Closure under the hood, and does this. System.js, which uses Rollup, can do this. Webpack 2, since I wrote this blog post, they have said they're working on it, but it's still in progress. As far as I know, they have not shipped it yet in their beta release. Sometimes it can be kind of tough, though, because a lot of these module bundlers don't play quite so nice with the NPM ecosystem. Webpack and Browserify are super battle-hardened. They will work with pretty much everything. The other ones, not nearly so much. So sometimes you might want to go into easy mode, as I would call it, which easy mode is just take your own code base and migrate that to ES modules, migrate that to import-export, and then use something like Rollup or Closure to build one giant module out of that, and then shove it into Browserify Webpack like you normally would. You're still paying the cost of the modules for your third-party dependencies, but at least you're not paying the cost for your modules in your own code base anymore, right? From the perspective of those bundlers, it's like you're giving them one gigantic index.js file. So, or I wrote a tool called Rollupify that does this for you if you're using Browserify. Another thing, I wrote a tool called Optimize.js, which basically what it does is it kind of hacks your JavaScript bundle by basically what it does is, so part of the reason that these costs are so big is that JavaScript engines will tend to defer parsing of functions. So the more functions you have, they'll try to avoid parsing those functions now, but oftentimes these module bundlers just end up executing those functions immediately. So in effect, they kind of get parsed twice. And what this thing does is it basically just it actually just inserts parentheses around all the functions, which tricks the JavaScript engines into just parsing it now. This can reduce the load time of your bundles, but this is something that I definitely want to caution people to actually test this. So actually measure this, use performance mark and measure it. Actually make sure that it has a benefit for your bundle, because there are bundles where it'll actually make it worse. So it depends from bundle to bundle, but a larger JavaScript bundle doesn't always mean that it will be faster to parse. Does that make sense? Like actually there was an example back here of Require.js is super interesting because it actually produces gigantic bundles compared to the other ones. You can see the blue is much bigger, it takes longer to download, but it's really fast to execute. And it's because it just happens to be structured in kind of this way where it doesn't pay such a high parsing cost. So, all right, that's optimizing bundles. Still doing okay? Okay, code splitting. So the idea here is really simple. When I go to your website, if you serve me up a gigantic 5 megabytes of JavaScript, I'm going to guess that I probably don't need all that JavaScript to see the front page. I'm going to guess you're giving me a lot of stuff I don't need. You're probably giving me stuff like, the About page, or the Contact Us page, or the Careers page. And you know what? I'm probably not going to click on that. I really don't need to get all that JavaScript on first load. So it's advantageous to split up your JavaScript bundle to lazy load pieces later on in the pipeline. So the target that Seth Larkin, who is one of the Webpack maintainers, has set out is try to target less than 300 kilobytes un-gzipped for each of your bundles. That's a good target. If you really want to get aggressive, Adi Asmani has said that if you really want to hit less than 3 seconds on 3G per rail, you want to get below 100 kilobytes per bundle. I know this seems, for some code bases, this might seem like inachievable, but remember, we are failing at performance, right? People are abandoning our sites if they take longer than 3 seconds to load, and we're at 18 seconds. So sometimes we need, to have some serious measures put in place to actually reach our targets. So I'm just giving you real talk right here. I know it's difficult, but this is so you can know. There are lots of code splitting tools out there. I'm not going to go through all of them. But basically, if you have Webpack, you've got Commons Chunk plugin, this require.ensure API, which is non-standard. I'm going to get into that a little bit later. This new aggressive splitting plugin you can use with HTTP2. Browserify has a cool thing called factor bundle. System.js does it. Require.js does it. Splittable does it. So learn how to use code splitting. Don't just not code split. And then this is getting standardized, this idea of having trigger-loaded modules in this import function, which has just reached stage 3, so it's very, very likely to become a standard. Basically, what it looks like is this. Normally, the way that the import and export syntax has worked is you would statically load by saying import static module from static module, like that first line, right? And that's just totally static, right? But then the new thing that's coming out is that import can also be used as a function that returns a promise. So you say import dynamic module dot then, right? Or await if you're using async await. And then you have this dynamic module, and then it's lazy loaded. And this is very, very likely to become standardized, so this is probably the thing you want to start moving towards in your code base. So try to avoid things like require.ensure, which is like a weird Webpack specific thing, AMD, system.import. Try to use the import function, which System.js is moving towards that. There's a Babel plugin that will convert the import function into require.ensure, so you can use that for Webpack. So start using this, start betting on this. All right, server-side rendering, or SSR. So to understand why server-side rendering is a useful thing, I think it's good to go over why client-side rendering is so slow. So to explain what I'm talking about, this is what I mean when I talk about client-side rendering, which is kind of like, this is almost like the standard in JavaScript development, in JavaScript web development for the past 5 years, right, is that you have this kind of empty body, you ship down empty markup, because who cares, right? All the action's going on in the JavaScript, so you might as well ship down an empty body tag. And then in the script, you got your humongous framework, right? And this is kind of a habit that we fell into in the web development community. You know, you think back to things like Angular 1, where they would tell you to add classes called ngCloak in order to tell it to actually hide all the markup until the JavaScript could load, right? That was considered a best practice. And the reason that this is slow, and the reason this has turned out to be slow, and everyone's kind of realized it's slow is this, is that here's the way this actually works, this client-side rendering. The browser makes a request, it starts receiving a bunch of HTML. And it's receiving that HTML, but it's all empty. It can't really render anything, right? And then when that's all done, when it gets to the bottom of the body, it gets the JavaScript. And now it finally can go fetch the JavaScript, and it can download the JavaScript and parse the JavaScript, which, as we established, can be quite slow, and evaluate the JavaScript. And then at the end of all of this ceremony, finally the user gets to see something. Oh, happy day, right? This is really slow. This is a really bad user experience. What is much better is this. This is kind of classic static web model, right? Where you make a request, and then you start receiving the critical HTML and CSS, and you show the users something. You know, even if it's just a loading spinner or something, give them something to look at instead of just a white screen. Even better, giving them the actual content that they came there to see is even better. And at that point, the user actually starts to see stuff. Then they continue to get HTML. HTML continues to load. And then the JavaScript can load after the user is looking at something. And then your JavaScript app can kind of bootstrap. And this is great for perceived performance, right? Because the user feels like the app is loading faster. They're not just seeing a white screen for a long time and then bam, content. Like they're seeing something along the way. This goes by another name, which is progressive enhancement, where the idea is basically that like you have like your critical HTML and your CSS in the head here. And the nice thing about that is that, hey, this H1 tag, like as soon as I see that, the browser can actually start rendering that right away. I mean, how about that? That's actually like a really nice feature. And it turns out there's a lot of nice features that you throw away when you do the gigantic JavaScript bundle style. Like there's things that browsers have been optimizing since forever because it turns out browsers are really fast at rendering HTML and CSS. They've been doing this for a long time, you know. So things like images, for instance, like browsers have a thing called a preparser where they will go ahead and they will do the full HTML parse, but then they have another one that runs at the same time that just quickly looks ahead and tries to find resources like images so they can go out and just prefetch that image. And this is all the kind of stuff that you're throwing away if you just jam everything into one big JavaScript bundle. So that being said, before a few years ago, this was actually kind of hard to achieve, like if you were doing Angular, React, this kind of JavaScript development. But to the framework's credit, they have realized that this was a big problem with their design, and nowadays it is table stakes for any JavaScript framework. They need to have a server-side rendering solution, and they all do now. So Angular 2 has it. It's called Angular 2 Universal. Ember has it. It's called Fastboot. They were one of the first ones to have it, actually. React has server-side rendering. Vue.js has server-side rendering. If you're not using a framework that has any of these, you should move to one of these frameworks. Ideally, if you cannot, there is a tool called pre-render that will basically just render your JavaScript app into a Phantom.js headless browser and then spit that out to a HTML string. Okay, last part of the talk and most exciting part of the talk for me, because I love this feature, is component pre-compilation. Oh my god. This is so cool. You guys, you're going to love this. It's amazing. Okay, so to explain what component pre-compilation is, let's start with a thought experiment. Let's design a JavaScript framework. Let's sit here and do it today. I've got like 3 minutes left in this talk. We've got enough time to design a JavaScript framework, right? So I'm going to design a super simple JavaScript framework. It's going to be kind of, inspired by handlebars, and it's going to look kind of like this, right? I'm going to have my template. I'm going to say, hello, something, right? And then in my JavaScript, I really want to be able to say render name, and then ultimately what this is going to say is hello world, right? So super simple template. Now let's think about how we could implement this. There's a couple different ways we could do this. The naive way is we ship a full template parser to the client, right? Something that is capable of understanding every single possible way of using those templates, or we ship that all to the client as this gigantic JavaScript engine, and then we evaluate everything on the client side, right? That's the naive way. Or the really clever way is we realize, hey, I've written this template compiler in JavaScript. We have a thing called Node.js. I can just do this all on the server side in advance, right? And spit out some kind of very optimized version of this, right? I mean, the simplest version of this should just be one line of code. It shouldn't be a whole runtime. And this is what many of the frameworks now are starting to do. Angular has it. They call it ahead-of-time compilation. This is only in Angular 2. And the performance benefits of this can be pretty startling. So this is just a very simple example that Rob Wormald of the Angular team put together to demonstrate ahead-of-time compilation. It's just a really simple, small progressive web app. I think it shows the weather or something. And you'll see that before doing AOT, we've got 1.369 milliseconds of scripting. So tons and tons of scripting, right? And then with ahead-of-time compilation, the exact same app, exact same experience, suddenly we got only 256 milliseconds of scripting. So it's been cut by nearly 1/10. And actually the JavaScript bundle size is about 1/10 for this. So huge difference. And all it's doing is just pre-compiling those Angular templates instead of shipping the full parser, the full Angular runtime to the client. So almost all the frameworks have this in some way or another. Angular 2 has it. They call it AOT. Ember has had it for a while. They call it Glimmer. In Ember 2.9, they actually have improvements, further improvements to the way Glimmer works. They have an even tighter format. It's a very trim little JSON file they ship down to the client. Handlebars has actually had this for a long time. They kind of pioneered this. Svelte, this one is really interesting. So this is a new framework that just came out a couple weeks ago, where basically their idea is to take this to the extreme. They have no runtime at all. They just compile all the templates down into pure vanilla JavaScript, which is nuts, but it's fascinating. Vue.js also has this. If you're using Browserify, you can use Vueify. If you're using Webpack, you can use VueLoader. Okay. I'm running short on time, so I want to get down to the closing thoughts. So I was really kind of struck by this article by Maciej Siglowski about the website obesity crisis. He made a lot of really good points about how we're failing to optimize our websites and failing to deliver a good experience to our users. And he ended, or he didn't end, but at one point near the end, he had this sentence, which is just this is so good that I'm just going to repeat it verbatim because I love this, where he says, in conversations with web performance advocates, I sometimes feel like a hippie talking to SUV owners about fuel economy. They have all kinds of weirdly specific tricks to improve mileage. Deflate the front left tire a little bit, put a magnet on the gas cap, fold in the side mirrors. Most of the talk about web performance is similarly technical. So I'm sure that if Maciej were watching my talk, he would say that pretty much everything that I just said is all of this kind of weirdly technical stuff, right? Like deflating the left front tire a little bit. Oftentimes a lot of it just kind of obscures a very simple solution, right? If you're just going to the grocery store, you don't need to bring your SUV all that way. You can just bring a bike or your skateboard. If you're just building a simple marketing website or the About Us page or the careers page, maybe you don't need to use a big JavaScript framework for that. Maybe you can just do the simple solution, and then you don't have to jump through all these hoops that I was describing before. Right? You don't have to worry about the fact that JavaScript frameworks are kind of slow by default. So as you're building websites, definitely use all these techniques, because I do kind of honestly believe that we can have the best of both worlds. I'm looking forward to see what bundler authors, what library authors, what framework authors do in the next few years to solve these kinds of problems and to let us have our cake and eat it too. But in the meantime, kind of ask yourself as you're building websites, like, do I really need all these libraries? Do I really need all these third-party dependencies? Do I need immutable JS? Like, it's useful, yeah, I guess it makes React a little bit more convenient. I don't have to write so much code in my should component update, but it's 16 kilobytes, minified gzipped. Do I really need all of RxJS? RxJS is really nice, but it's 40 kilobytes. Bluebird, it has some really great APIs, but there are smaller alternatives. Do I really need to support IE8? Do I really need to ship like this mountain of polyfills to all of my users, or can I just drop IE8 support? Is it worth it to support my 0.5% of web traffic or whatever that's coming from IE8? Do I really even need JavaScript? Like, there's this cool website, You Might Not Need JS, that shows all of the stuff that we're implementing over and over again in JavaScript with big JS-heavy solutions. Like, you can do it all with HTML and CSS. You kind of don't need JavaScript for a lot of that stuff. So think about that. Take into consideration the techniques that I've listed before, but keep your mind on the target, which is to build a faster experience for our users, because we're really failing to do that right now. And we have to kind of take a long look in the mirror and think about how we're going to address that problem. Thank you.